I think those who wanted to join has joined. So we'll start with if there is any question, we'll take first, and then we'll start with some of the tests which are you may not be familiar. We'll be taking those tests, and then something hands-on training on the AP Info if you have not used it, and there's any question on that. So meeting summary automatically generation. So let me any question? Vinay, Janish, Dishant, Rashmi. Okay, let me start with sharing my screen. Now, sometimes there are two referees, and we're going to find out whether there is any agreement within them or not. It could be a teacher and student, or it could be two doctors. Let's say two radiologists looking at the same X-ray diagnosis, whether one person says TB is there, other person says TB is not there. In such situation, there is a test which is known as kappa. And this kappa test is very interesting and very simple. What you need to do is only just fill in this 4 columns, right? Let's say take example between teacher and student. This rater A is a teacher and rater B is a student, and they are let's say examination of the crepitation. Some of them says that crepitation is there. Crepitation means respiratory sounds, particularly during various conditions like, let's say, bronchiolitis or the pneumonia, etc. So let's say both of them say yes in 40 cases. And when the teacher says no, but student says yes, I can listen to it. So there are 5 cases. And when teacher says yes, student says no in, let's say, 3 cases. And in 25 cases, both says yes, it is not heard. Now, if this is a situation, this is a 2 by 2 table. In this case, the kappa says that 0.77. That means relatively very good agreement. If the data is like this, 10, the 8, and here it is 25, here it is 18, then the agreement is 0.393. So it is you can say there's no agreement, right? And even it's minus. If you just change a little bit, and here 15 and maybe a 12, and here 16 is 0.1. So this shows that hardly there is any agreement between the teacher and the student. And if we say that teacher is a gold standard, then student needs to improve. Or there will be maybe a 2 judge in a competition and giving the yes or no to a particular, that is pass or fail, then this can be used. Those who would like to understand the formula in detail can do it in a later stage, and formula is already given, but understanding will take at least 20 minutes or 15, 20, how this the kappa test comes. But you can start using from today onwards. So you need to find out two raters saying yes, no, yes, no. You compare between the two tests also. Let's say sputum A, B versus X-ray chest for the diagnosis of tuberculosis. But then you need to have data for both the things, both the test data you should have. So in such cases, you can use the standard of difference due to proportion, you can use the chi-square test, you can use the relative risk, you can use the attribute risk, etc., in 2x2 tables. But that tables is giving what kind of data, that depends which test is to be utilized. Others 2x2 table could be of many permutation and combination. So here we are just talking about two judgments, two-person giving a judgment on a single items. Even you can do that, let's say only single person is that. Let's say Dr. Akshay is there. And today his judgment is like this. The same person's judgment you can check after 10 days. Whether how much change within that person also you can measure. One interesting thing is that if let's say Dr. Rathi has examined 40 cases. Cases means the answer sheets of students. And then he examines and giving pass and fail. And then next time, after 4 or 5 days or so, we just hide all the marks and ask that person to check again. And let's see that whether he passes or fails the person. And this is how the two judgment can be compared. The next file which we are going to, any question on this? You will be able to use this because I think this file is shared with you, or if not shared, we'll be sharing soon. Right?
But how to find out that PR bracket A, PR bracket E? There is a formula for that also?
So actually, how it calculates that the EA is an agreement.
Correct.
E is a probability of random agreement. Statistics is basically a comparison whether this event has happened by chance or because of some reason. But it says that PA is agreement, that means a real agreement. And randomly, if you just ask two person, even two illiterate people, to just that yes or no, just tell that. So randomly also, in few cases, both will agree, even if there is no reason behind that. So that is random agreement. So even if there is no reason, right? And agreement is the logic behind that. So if it comes around near to the one, that is a complete agreement or almost a significant agreement. And if there is no agreement, zero. So in no agreement, what happens that even if two person are unknown, not knowing about the subject, and even you go for random judgment, at least there will be some agreement in the case. So we are removing the effect of that random agreement, and then we are coming to the purely agreement. And that's why it is PA and a minus E. And this is 1 minus PRE because the probability is always out of 1. So it's a purely, you are removing the effect of a random agreement from the 1. So that is an absolute which is remaining for the there should be some reason behind. And on this also we are removing that factor random agreement. And so we get a purely A. And this way is a kappa the agreement. And here, if you go into detail, that why this is probability of random agreement P, what is the reason of P, then it is given over here. And if you have a formula for that, then it is written over here. See, L10 plus L11. That L10 and L11 is over here, this two.
Okay.
And this 2 is arrived by L6 into L18. L6 into L8. L6 into L8. And this is
Okay.
arrived by L7 and L9.
Mm-hmm.
There is a no and B. And this is a probability of, right? They are getting by E by F11. All this has the
Okay.
and this you, if you want to understand, it will take 15 to 20 minutes, and you can
Okay.
also understand by yourself also. It's
Yeah,
not
yeah.
time consuming.
Okay.
Directly use or just this for the cells, and you will get the result about agreement. This is a kappa test agreement. So any other question? So we'll be going for the next file. So one person asking that at what level we should take a kappa as insignificant, right? So for that particular matter, you should have series of this kappa agreement score in 10, 20, 30, 40 individuals or 50 series should be there. And then you find out the mean and standard deviation, and you find out the more than or less than 2 standard deviation. But if you don't want to do it like that, it's a usual judgment. It's a usual judgment that if it's more than, let's say, 0.7 or so, you can say yes, it's significantly agree with all of the each other. And if it's less than 0.3, you can say that yes, they mostly disagree with them, significantly disagree with each other. But there's an arbitrary. If you want to apply a statistical test for that matter, then you should be going for the series of such the pair of observation, and from that you will have a k, and from that k there will be a means of the k, and from that you will be able to find out which is outlier. But
Mm.
otherwise we can say that arbitrarily is above zero point 0.5, less than 0.5, but then 0.3 and 0.7, more the stringent you take a cutoff line, more will be your confidence that in your statement, yes, agreement. If you have more validity to that agreement, then it should be near to the one. Any other question?
Yes.
So kappa test, you will be able to do it.
Yes, sir.
Okay. Then we'll share other things. This is a very good method, is a lots quality assessment. A little bit difficult, but then very useful as far as the sampling technique is concerned. So here we have two files. And you should learn how to use this file. Excel file is shared with you. If not, it will be. Now, take an example that you are going to evaluate students in a university. Fine, fine. So in university, you have a class 1, class 2, class 3, class 4, like that. In each the class, there will be number of students. Here it is the number of village, and here number of or size of the population in each village. These two columns you have understood?
Mm.
Okay. Then the program will automatically write down cumulative population over here.
We can't see, sir.
You can't see, I've shared, so still you have not seen?
No, it shows LQAS village sampling for training. That session 1, section 4 table. We
Okay.
can see your folder names.
Okay, I will go again, I will stop and then go to the share screen again. Now, it's seen now.
Yes, sir.
So this you should know it because it is a very rapid technique to find out uh, just to find out whether the person passes or fails. In a sense, the vaccination taken or not taken, or patient is taking regular treatment, yes or no. In this case, you are concentrating on no factor. Out of 19%, the sample size is very small. The population may be, let's say, around 1 lakh, 5 lakh, or 2 lakh, something like that. And you are asking only 19 individuals. And based on that, you will be giving judgment on the population. The large quality assessment sampling is basically from the adapted from the factories and productions like that. First batch, second batch, third batch. In that, if they reject more than a particular number out of 19, then they will reject the whole lot. That there is something wrong over here. In this case, you have a taluka of, let's say, 1 lakh population. You have 100 villages. And you want to find out whether the people know about this PMJY services or not. Yes, select only 19 individuals in this method, the method which we'll be talking about, and ask them. And if a particular number do not know about that, then you can say that cover is not more than this. So the logic to understand behind this lot policy assessment again may take 1 or 2 hours or maybe a 30-40 minutes, but you should know how to use it. So basically, you are selecting, let's say, I will take you paste your villages over here, right? You select a few villages and you can delete even this, and you can paste other villages over here, which you have, right? Because the formula will remain over there. And here, your village and your population, you can paste. And we presume that you have 20 villages and you have pasted over here. Let us take a bit more villages to make it easier. And if you count like this, and we have sample size is 90. This also you can change. Instead of 19, you can write 22. Automatic sampling interval will change, right? So you should usually write 90. If you become very expert at the time, you may change. Right now, use 19. And then it will tell you that from where you are supposed to take your sample. This 111 says that you should select your sample from that particular cluster. So first village, you select 1 person. This village, you select 1. This is 1. Similarly, so what you are supposed, you have this file. So what you are supposed to do, write down the name of village here and write down the population over here. You have some Excel file and then copy paste over here. That's all. Your sample automatically comes over here. That you are supposed to take the sample from this village, this is like this. Now the question is that either is a village or is a classroom or it's a factory or it may be the temples like that. Whatever series you want to check. Then it is the matter of expertise that out of 991, whom I should find out. So you can go for a random number or you can find out the random society or random falia, random street or random road and the distance of the road from center to the periphery And that meters also find out the random number of meters. Suppose there are 7 roads. From the center, you draw 7 roads. You randomly select road number 3, and road number 3 is, let's say, 200 meter long. So 1 to 200, find out the random number, there is 167. So 167 meter, take up a spot, and nearest person is chosen. It is something like that. So if you choose this way, this 19 will not represent the whole population, but the coverage based on 19 will definitely forecast what will be in the population. So I hope you understood that in the 19 sample you are supposed to take. Now you are asking a question. Various series of questions could be there. If it's general population, you find out person from the general. It's a family head, find out the family head. If a diabetic patient survey, you find out from nearest point who is the diabetic patient. So if you are doing a survey of the animal, find out who is the nearest animal from that. If you are doing a survey of the house is kacha or pakka, you find out the nearest house whether it is kacha or pakka. So the format answer will be yes and no. And then out of 19, how many are saying no? That will give you the percentage. So once this file is over, we'll be opening another file. The question, the moment I close this file, I need to again probably share the things. Let me see whether I need to do it or not. Is this file visible?
Yes.
Okay. Now, it will require a little bit of concentration over here.
Sir, only the lowest village file is visible. Are you talking about that one only?
I want to
So
show
the
you
new file is not visible.
And so I will show you another file, which is which I want to show the result. Because out of 19, now you have a result. So 7 people said no, 8 people said no, like this, right? And then based on that, we want to find out a percentage in the population. What will be the percentage of the population? So now I think this file is visible to you.
Yes.
Yes, sir.
Now in this case, make it a large. File. So here the sample size, I told you, no, you can keep it 9 or you can, this is 19, 22, 25 that you can select over here. But usually you go for 19. And then if 7% says that no, we are not covered. For example, have you got the advantage of the widow funds or widow support, or are you taking adequate treatment for the tuberculosis or not, or whether the child is immunized or not? So whatever the question is, whatever the sample the sampling frame is there, you should have asked that person. So for timing, let's say for vaccination coverage, if out of 19 children, if 7 are not covered fully, right? Then in this case, you can see that if 7 are not covered fully, then you look at the answer over here, 50%. So you are sure that the coverage is not more than 50%. So it's if the government data says that our coverage is, let's say, 75%, but out of 19, 7% says that they are not vaccinated, then you are sure that it is not 75%. It is not 70%. That you can tell based on that. Other way around, out of 19 individuals, 12 says that they're not covered, right? They're not covered. So this is 75%. So you are sure that it is not beyond that. The coverage is not beyond that. See, it is not beyond 85%. So this cutoff line, this is the sample size you have. Then you have how many says no, and based on that, you find out the percentage over here. So suppose you have selected 22, sample is taken, and 5 people says that they're not covered. That means the coverage is not more than 40%. This is all this, if they say that 70% or 80%, you can say it is not there. You may not be able to say that how much people are covered, but you can say this much is not there. So it is a rapid survey to find out whether the coverage claims are proper or not. So this decision-making rules you should be using by this table. This is basically tells about probability. And that's out of this many sample, is this many says no, what will not be the coverage. This is how you read the table. Any question on this? This is alpha error. It is written that more than 10%, more than 15%. That means that usually you should be looking at this the blue area, because the instead of going for 15%, it is much better to go for 10%. So you remember only one figure, that out of 19, if 7 says no, the coverage will not be more than 50%. That's all. Just remember this much. Okay?
Yes.
And you have a now Excel file. So if you want to do rapid assessment of 10,000 students, 20,000 student classes are already given, try to use that. I will stop sharing over here. And then we'll go to the another file. So we have seen the, we'll go for the Mann-Whitney test. These are the non-parametric tests. I will just share the files over here. Dr. Divakar Sharma is a statistician who taught me this, the non-parametric test. And out of you people, sometimes you need to work with the clinician also. And clinician usually works in not a large data like what we are learning, or we are doing analysis, etc. So sometimes you need to work on a smaller data, like 10 or 15 or 8 cases of cancer, or 7 cases of lymphoma, or 12 cases of surgery, etc. And out of that, there is some result, yes or no, and there may be a various parameters. In that case, how to apply test of significance? In a large sample size, you go for Z test, you go for the AF test, etc. But in a small samples, we go for Mann-Whitney test or Wilcoxon sign rank test. Let's see, gradually we'll go stepwise, and if you can cover both, it's okay, or one also is okay. You are given this file, and try to read that file, because we are going to meet after Diwali, and the next date would be 8%, 15. So maybe around 20 or 21st, whatever the first Monday comes. Meanwhile, we'll be sharing something in the groups, and you can continually share your queries also. Now, this is two groups for the comparison purpose, and this is a non-parametric test, and because it's a very small data and doesn't follow any pattern like normal distribution curve, etc. Right? And it will mimic t-test. And we'll have two sets of data, right? These are the two set of data. You may not be able to see the complete because of my screen limitation. And then, so first what we are doing, carefully look at this data. We are ranking them. Now, these two data sets are there. What is the lowest? And the lowest figure is 1. So 1 is naturally given the rank. This is not equal to sign is giving a rank. Can you see this? Fine.
Yes, yes.
Yeah. So the lowest number is given first. Then another same lowest number, then 2. Then you can see this the rank 2. So it is given third. Another 2. Then fourth. Then there is no 2. So third is fifth. Say another fifth. Third is sixth. I think you digest this step and then we'll move further. So this is how you are going to rank the data. Because actually what happens in a very, very small data, you are arranging them in terms of with the first or second or third. And then from that we are going to get the average, etc. In such a small data, if you want to find out a mean and compare standard of difference into mean, that is not possible. So we are using this non-parametric test. So this is a harmonization of the ranks. Now what is the next step? We gave a rank, but for one it is 1, another one is 2. So it is not the proper thing. So what you are doing in this data set, you go for average of that. Say one was given 1, another one was given 2. So what is the average between 1 and 2? 1.5. So for that rank 1, 1.5 is assigned. Similarly, if you look at the number 4, it is 9 and 10 and 8 and also 7. So there are 4, figure of 4, then this one is 7, 8, 9, 10. So all these 4 are grouped together, divided by 4. The answer is 8.5. So wherever there was 4, whether the rank was 7 or 10, we assign the value of 8.5. So till now, this test is easy to understand. So now we go for the next step. And this is required in case of very small data. Now, once the data are ranked, the formula looks very difficult, but it is not that difficult. You will see that it's relatively easy. Now, this treatment, add up ranks for each column, call this Rx. There are 2 series, right? X and Y. So if make a total of X, it is Rx, and total of Y, it is Ry. And this N and N plus 1 by 2, that's to compare whether you have done any problem or not. It should be equal to this. N is the total number of N. And the calculator value Ux and Uy, they are the basically a special calculations done from that. In that Nx means total number of sample size in X, Ny means total size of sample in Y. Similarly, there is a further calculation. So this Ux and Uy are required because whichever is a small value, Ux is smaller or Uy is smaller, that we are going to take that we are going to use for. Now this is a formula because ultimately we want to convert into a Z score, and Z score we know the Z table. If Z is more than 2, P is less than 0.05. But to arrive at the Z, there is a special mechanism in our parametric test. What we are doing, that the 5 types of Z were there, and if we can calculate Z is equal to, for example, x1 minus x1 minus x2, right? X1 bar minus x2 bar divided by SD, SE. So
Yes.
that way we are finding out Z in different, the 5 were there. But in this case, there's a special formula by which we are using the Z. And the calculation of N1, N2, etc., you need to take pen and paper with this PPT and try to do it. It is given like this. So the same data is over here. Only thing that they have applied the formula which was given in the previous slide, and then they're finding out that the UX and UI you will not be able to see because of this one thing. You will not be able to see on this slide. Probably you might be able to see this. The calculation UX and UI. I'm just showing the previous slide. In your notebook, when you calculate this, try to write this formula. UX is equal to NX into NY. This means total number of sample size, right? Plus sample size of X into NX plus 1 divided by 2 minus RX, total of that. So this is how they will calculate. And out of this UX, one is 3 and another is 39. So the lowest value is taken over here. And then the further calculation will be Z will be calculated, and it is 2.57. So now, based on this, it will say that whether the significant or not, because it is Z is more than 2. There's a significant difference between these two samples. That is what they will arrive at, right? So just speedy the recapitulation or revision. First thing, Mann-Whitney test is used when you want to compare two groups by ranks, or even I would say the score even are there. Then you can also compare that. And in this example, it was given 5-4. There's a basically it's one kind of it could be that number of marks, or it could be a number of the lumps in the body, or you can say the success rate. So these are the individual readings in which you have given some kind of the measurement values. And these measurement values with these two, they are significantly different or not, that we want to find out. In one group, there are only 7 observations, another group, there are only 6 observations. This we want to compare. So we give them rank. Then based on that rank, we applied the formula. And then we found out the lowest U. And based on that, we found out the Z score. And ultimately, Z was more than 2.57. That the original data of 7, data 7, and another data is 6. These two differs significantly. This we arrive at. So if there's any question, we'll wait for that, or we shall go to the another non-parametric test. Tomorrow itself, you need to read this file and calculate yourself. And I hope that in your clinic, for example, in ward A and ward B, number of days required for recovery of the patients. So 3 patients, days, 4 days, 8 days, like that. On another ward, these are the number of days. Then you can compare. If you have 100 patient data and 50 patient data, then you can go for standard error of difference between 2 mean or t-test or f-test, like that. But when you very small data, then you can go for Mann-Whitney test. So I would not ask you the understood, you will say definitely no, but have some idea about this?
Yes, yes. So how much small, but how much small should be the data? Less than 30?
Usually, see, 10, 15, 20 like this. So if such a small data, then you go for this. In otherwise, say data is like, let's say 20, 25 like this, then you can go for t-test. There is no problem in that, right? If a data is large, 50, 70, 80, then that is, you can go for z-test. And if the data is 80 and if you go for t-test, it is almost equal to the z-test. So small sample, I mean to say that 7, 8, 12, 20, 12, 13, 14. So, but if you apply this by chance, if a data of 25, you will not be wrong, but it is a difficult and there's more time consuming. So, you go for t-test. So very small sample, 7 or 8, you can, if you go for t-test, it may not be tell you the right thing. Next would be the Wilcoxon sign rank test, because sometimes the difference would be may go from the negative side also. Person are suffering from a pain. So instead of reducing pain, its pain may increase. In such condition, there will be minus and plus. And to remove this minus and plus, the effect, but still retaining their effect, the negative side or positive side, pain reducing or increasing, this Wilcoxon sign rank test is used because you are considering this, whether this the negative effect is there or positive effect, and you balance that, and then you consider the result. So here also you can have pre and post test, and this sum of ranks for a positive difference, sum of the ranks for negative difference. Out of this, you go for the minimum one, and based on that, you will be finding out whether there is a significant difference or not. Now, we are not a statistician, so we need not go into details of each the formulas and all those things. We need to understand that if this situation is there, we can apply this test. And if we know this kind of the formulas, etc., at least it will be easier to have access to the statistician help. Basically, I need to read it because this will clarify why it is using this Wilcoxon sign rank test. A pain researcher is interested in finding methods to reduce lower back pain in individuals without having to use drugs. Nowadays, the naturopathy and Ayurveda and so many people are there, right? The researchers think that having acupuncture in the lower back might reduce the back pain. Now to investigate this, the researcher recruits 10 participants to their study. At beginning of the study, the researcher asked the participant to rate their back pain on a scale of 1 to 10, with 10 indicating the greatest level of pain. So it will find out the pain is reducing or decreasing. After 2 weeks, he asks again to indicate their level of back pain on the same scale. He wishes to understand whether the participants' pain levels change after they had undergone the acupuncture. So there are 10 participants. Before and after comparison is going to be there. Now let's see what happens over here. We'll study the data. Can you see this file?
Yes, sir.
So first thing is rating before the therapy. How much pain? The first individual had a pain at a level of 5, then reduced to 2. Second person from 8 reduced to 4. But if you look at the patient number 4, the pain was level 4, but increased to 7. That means if it is reduced, we say positive sign. If it is a pain is increased, we label it as a negative sign. So it is not that difficult to understand this, the formula. And then the actual, the difference, +3, +4, -3, etc. is written. Now, if you remove the sign, then you will get the absolute value. And now once you have got absolute value, then like the previous example, we are ranking them from 1, then 2, again it is 2, so you rank 3, like this. So you are now export the ranking 1 to as much as goes on. So number of data. This data is 10, but 1 is 0. So in this case, you get 1 to 9, right? Now here, you take again an average, because 3 is 4, another 3 is 5, another 3 is 6, another 3 is 7. So for against all the 3, what you give a rank, the average of this 4 and 5 and 6, 15, 15 and 7, 22. 22 divided by the 3 are 4 times. 22 divided 4, that means 5.5. So apply 5.5 wherever there is a 3, right? Similarly, the rank, you make an average of the rank. And then sign of the rank would be based on this sign, plus or minus. So till, have you understood this table? Any difficulty?
Yes, sir.
So now what next? Now we'll go for W, the total of it. So plus signs are 33 and minus sign are 12. If you look at over here, there's a lot of improvement, but there is something, the problem was also there, minus sign. So it took a W, total plus sign are 33, minus are 12. So the 12 will consider this. The test statistics W is 12, and the critical value from table is 8 for two-tailed p-value 0.05. Now this 12 and 8, this is each and every table, Z table, T table, the chi-square table. You should have two things. One is the table value and another is the calculator value. And this comparison will give you the interpretation. So let's go the value based on W. Now this is the table given to you. You may not be able to see with clarity over here, but in your files which is given to you, you will be able to see it. Now in this case, the total number of sample, the pairs were 10. And if you look at the level of the 0.05, the value is the miss is written is not clarity, but it is 0.05. So this is a 8. Now this is a table value 8, and our calculator value is a 12, right? So you can see that where the 12 is going on this side. If it is a 5 or if it is 3, it will go in this side. So it's the table value is 8 and you are getting 12. What does it mean? If it is a, let's say, unfortunately it moves around.
It is more than 0.5. That means it is more than 0.5. It is going on.
So if it is a, suppose instead of 8, it is 5 or it is 3, something, it would go from this side. But 12 will go on this side. So the probability of this is occurring by chance is more than 0.05. So we say that this difference is not statistically significant. That's what we can find from this. Suppose instead of 12, if the figure was 5, then we can say definitely this is statistically significant difference. So in that case, we can say that the person has not achieved significantly difference by that acupuncture. This is what we can say, right? Suppose the number of are 15 and the calculated value is 22. What will be your interpretation?
It is between 0.5 to 0.2.
So it is 15 and you get the value 22, W22. What will be your interpretation? It will come somewhere around here.
Yeah,
So p-value is less than 0.05 and you can say that it is significant.
Yes.
This is how you can use the sign rank test. So we have seen two parametric tests. This right now.
Non-parent.
Two, Mann-Whitney U test and Wilkinson sign rank test. These are the two the non-parent tests we have seen. We have also seen the lots quality assessment test, and we have also seen the kappa test. Now, we will be going for some of the methods which are going to utilize in your research. So you can share which the project you are going to do it. You have enough time in the Diwali, and I wish that all of you select such a the topic or whatever may be the topic, but your questionnaire should be in such a way so that you can do all this kind of test. So when you are going to do a pilot test, take a small sample size and apply this non-parametric test. And when you do the actual study, then you can go for all the 5 types of Z test, and also you should be using F test, etc. And when you prepare the Excel file, you should be able to use the AP Info software. So if there is no question, we'll be directly going to AP Info software again, just for 2-3 minutes. Any question? Vinayak ji, आप कुछ बोल सकते हैं? Which test you are going to take? And I wish that you find out how to apply this test in create a situation. Dr. Alvin, Lisan, you are listening?
Yes, sir.
So which statistical test you are going to use, or which study you are going to do in future?
I'm not sure yet, sir. Like I have multiple topics in mind, but I haven't yet decided.
Select any one topic and then start doing at least very small test, no? If you don't do it today, you will forget. So this AP Info, I'll be seeing this share the screen. Can you see this AP Info is not visible?
Yes, it is visible, sir.
Yes, sir. It's
AP
visible.
Info screen, right?
Yes.
So, just write in the chat box if you have started a use of AP Info.
Check box.
Even if you use once, then write yes. Dishant is used. Anyone else? Even if you're not using it, simply write no.
Yeah. No, sir, not used. I have not used up.
Any problem in using that?
No. No, I have gone through it. What is it? Stack, cal.
But at least use it once, because he is so simple, and the more you know, the more you will have interest. Otherwise, it's difficult. There will not be interest initially. So this create form and enter data little bit tricky. You may not be able to understand clearly. But then you need to use for that purpose tool. What we are concerned is a classic analysis. But just you start, let's say the new project, you can write over here, and you can say that you want to work in the community health project, health. And then where you would like to put this, and say this is okay. You would like to put it over here and keep it there. And then you need to write E test 1 AP Info. This is your project, and you can describe that why this you are going to use. You might use for lifestyle changes, etc. And then you have within that project that could be formed. It could be behavior. in the food like that. And then you say, okay. So a screen will be there. Now you can prepare the form. Even if you want to take the already done previous form, that also you can call over here from the template. And then you can say label, for example, over here. And the label could be form 1 for behavior change. You can do it in Gujarati also, in Urdu also, etc. And then the stars, new field, text. That means name of a person. You can write in detail. It will automatically abbreviate the thing, and you can change that abbreviation. Just name of person. And if you make it compulsory, you can give a compulsory also. You can repeat the last also. If a village name, you can say last. You say make it compulsory, it will make compulsory, right? Okay. So this is how you can prepare your form. But it's time consuming and you can learn gradually. And then you can enter the data inside. So you need not have any the software person if you learn this. Automatically, it's a software generator. And then, okay. So in a classical exam, the analysis, you use this classical, right? And you can use Excel file also over here. If your Excel file is there, you can use this XLS, right? And then you can browse and select this Excel file. But then if it doesn't read that file, you need to go to the XLS and reduce to the previous version, because FE info is not as fast as changing as Microsoft is changing. So usually if you want to use only the sample files, you can use the files given in the samples. Why we select Oswego? Because this is usually they give in the exercises, so it is easier for you to understand. And once you have read that file, it will tell you how many the records are there. And if you want to use any of this command, select, etc., then you should have the result. You should first take a frequency of all these commands, right? You just say frequency star, everything will appear. But if you go for, let's say, chocolate, then it will give only for the chocolate. So frequency, I hope you will be able to define. Tables command you should know. For example, the rows taken or not, and sickness, yes or no. This is how you can find out the tables command. Now, for the advanced user, you can use tables command like this. Say you can say the vanilla versus illness, but you want to stratify by gender, whether there's an effect of gender or not. So remove that effect. To remove the confounding variable, this is very useful. You can use this confounding variable over here, and you will get the right, the kind of the answer. This will give you the separate analysis for the females, vanilla versus illness. And then there will be for the male, vanilla versus illness. And then it will give the summary of the test. The summary will be given of both the table together. So this is an advanced statistics, but that is possible with this. And for using means command, you should be using means of age, because you can find mean of the age versus the, let's say, milk. Who took a milk? Aged or children. You can say that the milk taken by the elderly compared to the children, because the smaller people, 45 was the mean. Here mean was 36. But this difference was not statistically significant because p-value is 0.42. This is how you can find out the interpretation. So I think this is good enough for today, and try to take a help and learn a bit more also. And you should see that the output 43, if you can't locate the output 43, go in and search and find out where your output 43 file is there. All this data is stored in that file. So, and then you can cut and paste. And there's something over here, which is again for the advanced user. All this, whatever you write over here, that is being stored in program editor. And that all this you can save in a program. So if you are using today 100 commands over here, but you don't want to again run 100 commands after 1 month, then you save this over here, and then you can run that file next month. Just one command, all the 100 commands are stored. That is the beauty of AP Info. So this is also known as program generator. So I'm stopping sharing over here. If there's any question, it's okay. Otherwise, we'll be meeting after the next Monday.
So can you share that file, sir, Microsoft Excel file you have on this vanilla, chocolate, and illness? The example you use always. Can you share that to us, sir?
Say you go to the AP Info, go to the analysis portion, right? And
Yes, sir.
then the Excel file will come out of that.
Okay, sir.
And if you cannot extract, you just send me the message in the group, and I will extract from that, because AP Info imports also, AP Info exports also. So there's a possibility that AP Info will export into the Excel. I will export in the Excel, and then we'll send you the Excel file, so that you can do the analysis on Oswego as an Excel file, right? So I will do
Yes,
that.
sir.
But you need
Yes,
to
sir.
write in the group, and it is better to write between 11 to 4. That is most active part of my time, so that I will be able to send you.
Okay, sir.
But,
Sir, can
so anything else?
sir, can you send the PPT in which there are different tests?
I think the PPT I have shared in the group. Most of the PPT I have shared. And if I not shared something, I will share again. And tomorrow also reminded around 11 or 12, and at least one person, that I will put all this course on our education platform. And all of you are supposed to register on that, and you will get a free access to it. So around 10 or 15 PPT or this Excel file or LQS file, they will be in that course. We have a status course in that our education platform. All of you will have access to that. So even I would put that as the PPT today's what we taught, that also I will be keeping over there.
Sir, one last question.
Yeah.
I was planning to do my study on the antibiotic usage in the hospitals.
Hmm.
So can you just give me an overview? Actually, I'm not that much into research, and this is my first study as in such. So
you should write down whatever possible, where it is used, how it is used, when it is used, for whom it is used, which antibiotic is used, for which bacteria it is used, etc. etc. You write down. The difference between two doctors or practices, difference between two samples, like for urinary tract infection, what they are using, and then otitis media, what they are using. So first, try to formulate the questionnaire, what I'm telling you, right? about antibiotics used. And
Okay.
the dose, whether the patients are taking completely or not completing, there may be around 40-50 questions on that. Then you find out of the what will interest you, right? Or what is more important. On that day, I told you, the use of matrix. You have
Yes,
so
sir.
many things to compare. You have a limited time and energy. So out of that, what focus you will be focusing on what? So I have shared with you the PSBH, problem solving for better health. You try to read those things. So whatever I have shared, if you read that, automatically you have a lot of horizons. So in antibiotic, if you want to compare the response to antibiotic, you cure, not cure, and you compare one antibiotic to second, then there will be standard of difference to proportion, right? So
Yes, I was thinking about antibiotic usage and the antibiotic resistance trends in the area or
so
the hospital.
yeah, so the resistance in the Pseudomonas versus resistance in Streptococcus, both resistance also you can compare. And if you are going to rank it, right? So the 1 plus 2 plus 3 plus 4 plus, right? And then you want to say that previously was plus 1, now it's plus 4. So increase or decrease like this, then Wilcoxon sign and text can also be used. But my advice is this is antibiotic uses. So better go for standard difference into proportion, tables command as far as AP info is concerned. You start with that. That will be very simple.
Okay, sir.
So any other
Thank you, sir.
question? Okay.
No, sir. Thank you.
So try to at least write down method of study, whatever you want to do it. Share the formats, the population which you are going to take, and sample size you can try to calculate arbitrarily from the AP Info software. And I have shown you the StatCalc. There's a StatCalc menu in the AP Info, and that it will tell you how much sample size is to be taken. And one day I will tell you the relationship between the sample size and standard error. So how you can adjust your sample size based on standard error. That will take some time. Okay, thank you.